Okay, guys, we're going to do, say, 3.7, I believe, is what this is called. Use linear models to make predictions. So that linear model equation is always going to be in the form of y equals mx plus b, or so far it's going to be in the form of y equals mx plus b. So our objective here, I can use the slope and y-intercept of a trend line to make predictions, to make a prediction, I don't know, and draw a trend line to make predictions about a set of paired data. Okay, so Mehdi has a new tracking device that he wears when he exercises. It sends data to his computer. How can Mehdi determine how long he should exercise each day if he wants to burn 5,000 calories per week? So we have basically time spent exercising here, kind of like over the course of, I don't know, like maybe a month or so. Basically, like when he spent maybe 25 minutes, he burned around 150 calories. That's kind of like how we interpret those dots, right? But we have this whole set of data to work with, right? So what I'm going to do is I'm going to draw a trend line here. I'm actually doing this in pencil rather than pen because I want to make sure I get it right before committing. And the idea with the trend line is you want to put a line through the data, basically the middle of the data. And so the idea is you want to get roughly the same number of points on the top of the line as you have on the bottom of the line, and try to get a few points that are exactly on the line. So I'm probably going to like focus on this one right here because it's basically on a point right here, or on the grid here. And so I'm going to see if I can kind of just like estimate it like about right there. So in this case, we're going to have a proportional relationship because if he doesn't exercise at all, he doesn't burn any calories, right? So 0 minutes exercise means 0 minutes burned, right? Let's see, I got 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5. Yeah, that's pretty good actually. I got maybe I could have made it a little steeper, but I think that's pretty good. So what I'm going to do is I'm going to try to find two dots that are on the line or really close to the line. So I got one right there at 80. 700 here, and then let's find another point here. Well, actually, this one's pretty good. We can actually estimate that. It's at 30. It looks like it's pretty much right in the middle, so 30 and then 250. Okay. So what I can do here is I can put I'm gonna like use my slope formula, right? So m equals y2 minus y1 over x2 minus x1, and I got my 2 points here. I got my first point is 3250, and then 8700. Okay, x1, y1, x2, y2. So 700 minus 250 on top. And then 80 minus 30 on the bottom. Okay. Again, it's just the difference. 700 and 250 is just the difference that we would do if we were doing rise over run, right? Same kind of thing, right? So that 700 minus 250 is 450. That 450 is that 450 distance right there. And then on the bottom, we've got that 80 minus 30 is 50. So that 30 to 80. Right there is that 50, right? So that's kind of how those numbers match up. Okay, easy peasy right here. We can cross out those zeros, and then 45 divided by 5 is 9. So we have a slope of 9 calories, so 9 calories per minute burned. Okay, and then we have our y-intercept here at 0, 0. So our b value is 0. So we're going to write our equation is going to be y equals 9x plus 0, which is just 9x. And then we want to figure out if he wants to burn 5,000 calories per week. It's per week. Duh. So then we're going to take this 5,000. That's calories burned is the y-axis right here. So we take that 5,000 and plug it in for 9x. So we divide by 9 on both sides, and we get whatever that is. 5,000 divided by 9. It gives us 555.5. That's a lot of minutes per day. That's per week. Duh. Okay. So that's 555. Let's say let's round that up to 0.6. calories, minutes actually, per week. And then, yeah, that's right. Oh, per day, right? So we take that, divide by 7. So that, we'll say that 555.6 divided by 7. That's about 79 minutes a day. Whew, that's a lot. But I mean, that's a lot of calories, right? Okay. Okay. Yep, there you go. Because yeah, that's per week, and then that breaks it down to per day. Okay, use the slope to make your predictions. We have Michaela. I don't think anybody's actually a speed skater, so I just left Michaela in. Speed skater hopes to compete in the future Olympic Games. She researched the winning times for the past 50 years. If the trend in faster speeds continues at the same rate, how can she use the information to predict what might be the time to beat in 2026? Well, we already have our trend line right here, and we have our data points on this thing. So what we can see is that as time goes on, the winning time decreases, basically. So people are getting faster at this particular race every year because the time to complete the race is decreasing, right? I know you'd be like, well, shouldn't it be speed be going up? But it's not comparing speeds. I mean, it's comparing the time to beat the race, or to the time, the winning time, and the winning time is going down because people are completing it faster. Okay. So years after 1960, so that's our 0 right there. So years after 1960 to go to 2026 is 66 years. Okay. So we are going to figure out our slope and our y-intercept again. Our y-intercept is 2.4. It's really easy to figure out. Okay. And then our slope, let's figure out 2 points here that we can use. Let's use this one right here. Very easy. Let's do 0, 2.4. Okay, very easy to do a y-intercept right there. And then, let's see here. Actually, right there. Okay. The line, let's see. Yeah, let's use this point right here. 30, and then 2. Okay, so then 0, 2.4, and then 32. So then we're going to say 2 minus 2.4, because that's our x1 and y1, x2 and y2, right? x2, x1, okay? So 2 minus 2.4 on top, and then 30 minus 0 on the bottom. Okay, so that's negative 0.4 divided by 30. And this is going to be the time in minute. This is how much it's decreasing by. So 0.4 divided by 30 gives us, that's how much it's decreasing, minus 0.13, negative 0.013. So our equation is y equals negative 0.013x plus 2.4. And then how can she determine, how can she use the information to predict what might be the time to beat in 2026? So 2026 is basically, if we're starting at 1960 here, and we're using a prediction to go out, I think that's 66 years, right? If I could actually write 1960 is at 0. So then what we'll do is we'll say 2026 minus 1966 to figure out how many years that is. Minus 1960. 2026 minus 1960 gets us to 66 years. Yeah, that's right. So x is 66 years. Okay, because it's basically 66 years after the data started being recorded. So we'll take that negative 0.013 times 66 plus 2.4. So got this negative 0.013 times 66 is that, and then we add 2.4 to it, and we get 1.542. Let's say 1.5 seconds. So basically that's the time to beat in 2026, according to this data, is 1.5 seconds, right? She would have to beat 1.5 seconds in 2026. Scatter plot shows the relationship between the number of people at a water park and the temperature. How many people should the owners of the park expect at the water park when the temperature is 90 degrees? So this is super easy. We just take a look at the graph. I've got 90 degrees right here. We just basically draw a line straight up to see where it connects, and we've got that right there over to 800, right? So the water park should expect about 800 visitors. And this is super useful data for the water park because then they know how many lifeguards to schedule for that day. They know how much funnel cake batter to order, I guess. Anyway, it helps them make decisions about their business so that they can, make sure they are staffed correctly and they have enough supplies. Okay. Scatter plot suggests a linear relationship between the temperature and the number of smoothies purchased in thousands. So we've got this right here. It's going up by 8, it looks like. So 8, 24, 40, etc. So we're starting at 8. So that's actually our y-intercept right there at 8. And so we've got a 0, 8 right here. And then, we got a great point right there at 40, 32. Okay, and this is 0, 8. So those are our 2 points. So m equals 32 minus 8, and then 40 minus 0. 32 minus 8 is 24, divided by 40. So we can divide each of these by 8 to simplify, and so we get a slope of 3/5. So that's our rate of change. What is an equation that represents the situation? Y equals 3/5 x plus 8. Kaboom. Easy peasy. Again, that from here to here, right, we're going up 24 from 8 to 32, and then from 0 to 40. Right, that's where those two numbers come from, right? We're going up 24, and we're going right 40. Okay. Solve this equation. I'm going to subtract 6x to the other side to get negative 11x. I'm going to add 7 to the other side. These are my inverse operations to get to 33. I'm going to divide by negative 11. And I get x equals negative 3. There you go.